In this video, we will be looking at our 7th grade math review, week 14. We'll look at day 1, Monday, and day 2, Tuesday. Alright, we did a couple of these problems today in class, but I'll do one more. I'm looking at the bottom one, 110 to 140. We're looking for percent change. We define percent change to be our change divided by our original amount. Well, in the case from 110 to 240, the original amount is 110. Original meaning first. Our original is 110. So rewriting our proportion here, the original amount is 110. The numerator will be the change. Well, change means subtract. If we go to the store, we have a $5 bill, we buy something that costs $3, our change is $2. The clerk performed a subtraction. So I will subtract 140 minus 310. I'll look at the positive difference. That's 30. Now, since it went from 110 to 140, our change is an increase. In this case, the change is an increase. So now we can simply find the percent that is 30 over 110. Well, remember that percent means per 100. So I will set 30 over 110 equal to, carve out a little space here, x over 100. Percent means per 100. So I want to know what fraction, with 100 being the denominator, what numerator will be equivalent to 30 over 110. So the first thing is I can do a little reducing on the left-hand side. Both 10 go into 30 and 110. Essentially, I can cast out these zeros. 30 over 110 is the same as 3 over 11. Now I can cross multiply and solve. 11 times x is 11x. 3 times 100 is 300. Solving for x, I will divide by 11 on both sides. Dividing by 11, dividing by 11. So, coming over to my scratch paper, 11 into 300. 11 divides into 30 twice. 2 times 11 is 22. Subtract 8, bring down my 0. 11 into 80, 7 times. 7 times 11 is 77. Introduce a decimal and a 0, and a decimal above in the quotient. Bringing down my 0. First subtract, 80 minus 77 is 3. Bringing down my 0. We have 30. $11 into 30, 2 times. 2 times 11 is 22. Subtract and I get an 8. And you will see this repeating pattern happening now. Introduce another 0, bringing that down. 11 into 80 will be 7 times, and this will repeat infinitely. It's going to be 27.27 repeating, and we can round that to approximately 27.3. So in this case, x is approximately 27.3. That is 27.3%. That's my percent increase. Alright, so the answer on day 1, the final problem of the percent change, is approximately 27.3%. once again, percent change is the change over the original. The change is subtraction. Once we make that fraction, we'll simply set it equal to some fraction such that the denominator is 100 and the numerator is x. Then we can cross multiply and solve. Alright. Next we have some operations on integers problems. I will demonstrate this first one. We have 5 minus a negative 7/8. Remember, keep, change. When we're subtracting and we have sign numbers involved, we will keep the first number the same, change the subtraction to an addition, and change the sign of the second number. This will become a positive 7/8. Well, 5 plus a positive 7/8 is simply 5 7/8. And that will be the answer on this one. Alright. In the bottom section, we are converting between fraction, decimal, and percent. Well, remembering that percent means per 100. In order to convert from a percent to a fraction, or vice versa, we'll keep that in mind. Percent means per 100. So to say 38% means 38 per 100. I could simply write in here 38 per 100. That's the fraction equivalent. Now 38 over 100 can be reduced. What number goes into both 38 and 100? Well, 2 does. Both these numbers are even. 2 goes into 38 19 times, and 2 into 100 50 times. So 38% is equivalent to 19 over 50. Alright, to convert any decimal to a fraction, you will simply express the decimal over some power of 10. So I'm going to take this 0.65 and make it 65 over a 1, and however many digits I have after the decimal, I will have that many zeros. We call this number 65 100ths, and that's how we express it here. This is the tenths, and this is the hundredths. 0.65 is equal to 65 over 100. This again can be reduced. We can ask ourselves, what number goes into both 65 and 100? Well, 5 does. 5 goes into 65 13 times, and 5 goes into 100 20 times. So 0.65 is equal to 13 over 20. Well, what percent is it? We see it was 65 over 100, so that's 65%. Using these two examples, see if you can complete the rest of the table. Right. Day 2. Looking at the first problem, I get to the question sentence first. How many students are in this year's 6th grade class? Last year, the 6th grade had 350 students. This year, the number decreased 36%. Decrease means it got less. How many students are there this year? Well, let's use a bar model to see if we can approximate this answer. So, I'm going to draw my bar model. We'll break it up into 10 portions. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our whole amount will be this 350. $350. Well, each one of these bars will represent 10%. 10%, 10%, and I won't write that You get the idea. 10% all the way across. Well, what is 10% of 350? Well, we simply move the decimal one place to the right. 10% of 350 is 35. Okay, but we're looking for 36%. So 36% would be 3 10%, and then 6% of another one. Well, we could imagine if this whole thing is 10%, well, maybe 6% would be right here. If this entire bar was 10%, then maybe this is 6%, and this over here is 4%. It's a little bit less. Let's see if we can just kind of get an estimate of what this might be. Well, this is 35. This, of course, is 35. This is 35. Well, 6% and 4%. Those are close to half. Half of 35 is 17.5. It's a little bit more than that. So maybe this 6% is something like 18 or 19. I'm not sure. I'm going to say roughly 19. If this part's 19, then this part over here would be 16. Because 19 and 16 is 35, and this seems reasonable. 19, again, this is an approximate. All right, well, we want 36%. Well, 10, 20, 30, and 6. So we see we have 1, 2, 3 35s, and then our 19. So 36% of 350 is about 1, 2, 3 35s, 3 times 35 plus that 19. All right. We could come over to our scratch paper. 3 times 35 is going to be 105, and 19 will be 124. This is 124. So 36% of 350 is 124. We want to know how many are this year. We need to do a subtraction. We would do 350 minus 124. Borrow. 10 minus 4 is 6. 4 minus 2, 2. We have approximately 226. All right. How could we find this is an approximate answer. Approximate. Okay. How could we find this exactly? Well, we could multiply. If we decrease by 36%, how much percent would remain? Well, 100 minus 36 is 64%. So we want to know what is 64% of 350. We could simply multiply, taking 350 times the decimal equivalent, which is 0.64. All right, let's do this multiplication, and hopefully we get a number nearly 226. 0. 4 times 5 is 20. Carry my 2. 4 times 3, 12, and 2 is 14. A 0 placeholder. 6 times 0 is 0. 6 times 5 is 30. Carry my 3. 6 times 3, 18, and 3, 21. 0, 0, 4, 2, 2. And we have 2 places behind the decimal in our factors, thus the product will be 2 places to the left. So we see the exact answer is 224, very close to our approximation. The correct answer on day 2 is 224. Right. I'm going to do one in the bottom that is one of our two-step equation problems. It says solve the equation, show all the steps. Well, let's say I want to complete the second one. I want to solve for g, that is get g by itself. Currently we have negative 4 times g and then subtracting 24. We need to undo both operations that are occurring with my g. I will first undo the subtraction. The inverse of subtraction is addition, adding 24 to the left of the equation and 24 to the right. 24 cancels with 24 to leave negative 4g. Actually, negative 24 and positive 24 add to 0, but we don't have to write the 0. We just have negative 4g remaining on the left. 8 plus 24 is 32. Well, we want to get the g by itself. What operations are going on between -4 and g? Multiply, because they're connected. We know that implies multiply. The inverse of multiply is divide. Dividing by -4 on both sides. -4 divides with -4 to leave g. 32 divides -4, that's -8. When multiplying or dividing, if the signs are different, the result is negative. We think that g is -8. We will now take the -8 and substitute it into the original and see if it works. Alright, so our original statement was -4 g, but we think g is -8, minus 24. Question, is that equal to 8? Well, -4 times -8 is a positive 32. 32 minus 24. 32 minus 24 is 8. So we are left with the statement 8 equals 8, which obviously is true. Thus, g equal -8 is a solution. This is a value of the variable that makes this statement true. See if you can work the rest of the problems.